Welcome to an algebra video tutorial learning about linear equations and vertical lines. So in this problem we're going to dig into, as we're talking about linear equations, slope-intercept forms, slopes, writing equations of lines, we're going to really dig into this special case of vertical lines. How do we write equations for vertical lines? How do we work with vertical lines? What are the slopes of vertical lines? We're going to answer all those questions in this video here. So I've got a vertical line drawn out here on a graph. And vertical lines are just a line that's straight up and down. So let me pick some points here and then we'll start digging into this thing. So if I pick some points on this line, this first one has the coordinates 3 for x and then up 8 for y. Here's a point right here, over 3 for x, up 3 for y. I'm going to pick the actual x-intercept here, so over 3 but a value of 0 for y. Let's do this one, over 3 and down 1, 2, 3, 4, 5. And that should be pretty good. So there we got 4 points on the line. And let's see what we have going on here. So in this case, my y values look like they're changing. They're decreasing, going from 8 to 3 to 0 to negative 5. But my x values are locked in. They're all 3, 3, 3, 3. And if I picked any other point, any of these points on the line are all going to have an x value of 3. And there you go. We've just discovered how to write an equation of a vertical line. So all vertical lines have the equation x equals a constant number, x equals c. And all that is because I want all the points that satisfy x equals this number. So if we look at our specific line that we were working with, all the x values are 3, so the equation for this line would be x equals 3. I want all the points that have an x value of 3, put them all together, and that makes a line. Notice there's no y variable involved. It's just concerned about x. I don't care what y is. Y can change. It can be 5, it can be 3, it can be 0. But as long as x equals 3, those are all the points that I want. So it's a special case because normally when we work with lines, we have x and we have y, and we're determining the relationship between x and y. But in this case, we're just concerned about x equals 3. All right. So that's how you write equations of vertical lines. If I wanted to come up with a different line here, if I drew this vertical line, oh, that's a bad vertical line. Let me draw a better vertical line here. Let me pick it right on the point. That's also, that'll work. It'll work good enough. So if I look at this line, and it's crossing over here at an x value of 1, 2, 3, 4, 5, 6, negative 7, the equation for this line would be, well, all the x values that are equal to negative 7. So essentially you can just find the x-intercept, and if it's a vertical line, that leads you to the equation, x equals negative 7. All right, let's get a little bit into the slopes of lines. Let's go back to our blue line here. We're going to pick a couple points. If you remember, the slope of a line is equal to the change in y. How much is my changes happening along my y values? Divide that by how much change is happening along my x values between a couple points. And the slope is just the average rate of change. It's just telling you how much change is happening for both variables in this line. So if I take a couple points here, let's take 3, 8 and 3, 0. And let's find the slope between those lines. So the change in y is going to be 8 minus 0. And the change in x is going to be 3 minus 3. Well, let's look at what we got here. 8 minus 0 is 8, and 3 minus 3 is 0. And what do we have going on? So this is telling me, all right, as x doesn't change, there is no change in my x values, but there is a change of 8 in my y values. However, if you go to simplify this, if you pop 8 divided by 0 in your calculator, you get an error or you get a message saying undefined. They may not have an exclamation mark. I'm just throwing that in there for emphasis because dividing by 0 is one of those mathematical things that we just can't do. You can't divide something into 0 pieces. We can't fit zeros inside of 8. We just can't ever divide by 0. So when I'm looking at the slope, if I have a vertical line, we've done the slope formula, we get to this point where we have a number divided by 0, we actually have to stop. And we recognize, oh, there is an undefined slope. We actually call it that undefined slope on all vertical lines. And that's kind of one of the hallmarks or one of the main characteristics of vertical lines is if it's a vertical line, there is no slope. It's undefined. So horizontal lines, if you remember, have a slope of 0. This is not 0. This is just undefined. I can't think about something changing in this case because there is no change happening. Usually when we use linear equations, we want to know, okay, as my x variable changes, which is oftentimes like time or minutes or something like that. We want to know as my x variable changes, how does y change in response to this? Well, vertical lines don't have any change in my independent variable x. So we get an error when we think about how does one change in one variable affect the change in the other because we don't have that kind of relationship going on. Okay, so to sum it all up, if you have a vertical line, you can write it with this equation, x equals some number. That number is the x-intercept. We did a couple examples there, x equals 3 or x equals -7. The slope of vertical lines is undefined because you can't divide by 0. So if you're asked to find the slope of a line and you crunch it all out and you get something divided by 0, you actually write that there's an undefined slope. There is no slope, it's undefined. And every vertical line has an undefined slope. Hopefully that's helpful for you, understanding special cases of vertical lines.